The Zoom session is being brought to you by the Fractal Recursive 12 Star. All right, for today, we'll be doing 1-1 about the coordinate plane and 1-2 graphs of functions. Okay, the coordinate plane is a way to go mediate between algebra and geometry. Algebra is traditionally done on the plane, and geometry and as geometry, and algebra involves variables, x's and y's, rather more than a left-brained abstraction. The idea is to associate points in the plane with pairs of numbers. You do this first by setting up what are called coordinate axes. One is a horizontal line called the x-axis, another is a vertical line called the y-axis, meeting at a point called the origin point. You have to choose all three of those. Okay, fine. So for any other point on the plane, you do is you drop a perpendicular to the y-axis and a perpendicular to the x-axis, making a rectangle. And these two sides are x, and these two vertical sides are y, and the coordinates of the point are called x by y. All right, so in this, the two lines divide the plane into four quadrants. Here are all the points where x and y are both positive, called quadrant 1. Here, quadrant 2, x is a negative, y is positive. And here, quadrant 3, both x and y values are negative. And here, quadrant 4, x is positive and y is negative. On this, the y-axis, y is always 0. So these are the points x by 0. On here, the x-axis, x is always 0. So these are the points 0 by y. Now, okay, if you're going to do geometry, one thing you might want to know about is the distance between points. Given one point x1 by y1 and another point x2 by y2, what is the distance between them? Okay, well, this horizontal distance, it'll be this length is the distance between the x values, x2 minus x1. This vertical distance has a length equal to the difference between the y values, y2 minus y1. So we have a right angle triangle. So by the Pythagorean theorem, d squared equals x2 minus x1 squared plus y2 minus y1 squared here. And so therefore, taking square roots, d is a square root of the sum of the squares of differences of coordinates. That's 4 ofs in a row. Square root of sum of squares of differences of coordinates. x2 minus x1 squared plus y2 minus y1 squared, all take square roots. Another elementary geometric idea is given 2 points, what is the midpoint between them? x1, y1, x2, y2, what are the coordinates of the midpoint? Well, its coordinates are the averages of the coordinates. So its x value, its x coordinate is the average of x1 and x2, x1 plus x2 over 2. Its y coordinate is the average of the y values, y1 plus y2 over 2. So a midpoint is an average point, so to speak. So for example, okay, so here we have some points, how we're to plot them. 0 by 5, negative 1 by 0, negative 1 by negative 2, and a half by 2/3. 0 by 5, x value is 0. So it's on the y-axis and it's up 5 units, 0 by 5. Negative 1 by 0, this 0 means that the y value is 0, and so it's on the x-axis. And so back a distance, negative 1. So here's negative 1 by 0. Negative 1 by negative 2 is back 1, down 2 in the third quadrant here. And a half by 2/3 is in the first quadrant, over a half of 2/3 here. Here are 2 points, negative 3 by 3 and 5 by negative 3. What's the midpoint between them and what's the distance between them? Okay, to find the midpoint, the x value is the average of negative 3 and 5, negative 3 plus 5 over 2. The y value is the average of 3 and negative 3, 3 plus negative 3 over 2. After a little bit of work, it's 1 by 0, there's the midpoint. The distance between them, well, we'll use the distance formula. Square root of a sum of squares of differences in coordinates. The coordinates are negative 3 and 5, so negative 3 minus 5, square that, plus 3 minus negative 3, square that. Okay, this is negative 8, square that. This is 6, square that. 64 plus 36, square root of 100, distance is 10. All right. Here, some points, negative 3 by negative 6, 4 by 18. Plot them, find the midpoint, and find the distance between them. Negative 3 by negative 6, back 3, down 6, right here. 4 by 18, over 4, up 18, up here. Now, For the midpoint, we take the average of coordinates. -3 plus 4 over 2 is the x value. -6 plus 18 over 2 is the y value. This works out to be a half. This works out to be 6. So the midpoint is a half by 6, roughly around here somewhere. The distance, you take the difference of the square root of the square root of the sum of the squares of the differences of coordinates. -3 minus 4 here, square that, plus -6 minus 18 here, square that. That's -7 squared plus -24 squared, which is 49 plus 5, 76. Comes out to the square root of 625 is a whole number, 25. This is therefore a 7, 24, 25 triangle. Now here I have a similar thing for 7 by 3 and 11 by 6. Okay, 7 by 3 over 7 up 3 here. 11 by 6 over 11 up 6 here. Midpoint, we take the average. 7 plus 11 over 2 makes a 9. 3 plus 6 over 2 is 4.5. So the midpoint is at 9 by 4.5, roughly around here. The distance, okay, square root of sum of squares of differences. 7 minus 11, square that, plus 3 minus 6, square that. That's -4 squared plus -3 squared is root of 16 plus 9 is root 25 is a 5. This is a 3, 4, 5 triangle. All right, here we have 3 points. I want to know which of these 2 points is closer to R. So find the distance from P to R and the distance from Q to R and find out which is smaller. From P to R, it's root of 3 minus -1 squared plus 1 minus -1 squared. From Q to R, it's -1 minus -1 squared. 3 plus 3 minus -1 squared here. And after a bit of work, this is root 20 and this is root 16. 16 is smaller than 20, therefore so is the square root of 16 is smaller than the square root of 20. So Q is closer to R than P is. Now here we have a cute one. 4 points, -2 by 9, 4 by 6, 1 by 0, -5 by 3. Prove that these are the corners of a square. Well, all right, so from distance from A to B, from B to C, from C to D, and D to A, we use the distance formula. 2 minus 4 squared, 9 minus 6 squared works out to root 45. 4 minus 1 squared, 6 minus 0 squared, square root 45. 1 minus -5 squared, 0 minus 3 squared, 45. -5 minus 2 squared, 3 minus 9 squared, root 45. So these are from A to B, B to C, C to D, and D to A are equal distances. That's not a proof that it's a square yet, though. It could be a rhombus. You have to have also the diagonals between opposite corners are equal. So from A to C, that's -2 minus 1 squared plus 9 minus 0 squared. That works out to root 90. From B to D, 4 minus -5 squared, 6 minus 3 squared. And work that out as root 90. So yes, the 4 sides are equal. The diagonals are equal. Therefore, this is a square. Okay, that's that for that part. Just a second.